Assalamualaikum everyone. So today we'll continue on the chapter 4 arithmetic instruction on the condition codes register CCR for add subtraction instruction. Okay. So uh, so this is uh, the flag. Okay, this is also called the flags, which is this is the flag or CCR that we will consider for this course. So we will not touch on the red box, only the blue box. Extend, negative, zero, overflow, and carry. Okay. So for this one, it is related to the status register. Okay. So previously we have learned about five type of register inside CPU. Okay, you can try to refresh back on the chapter 2. Okay, so inside the CPU there are data register D1 to D0, address register A0 to A6, then A7 is stack pointer, and then there is also a program counter and status register. So for this lecture I will focus on the status register and a bit about the program counter. So program counter, okay, labeled as PC. Okay, there is one numbers, okay, for the program counter, and it is a 32-bit. Okay, the definition is contain the address of the next instruction to fetch and execute. Okay, contain the address of the next instruction to fetch and execute. Okay, actually program counter is quite simple. Okay, we can just try to see in the easy 68k. Okay, for example this one. Okay, you can just write any program because you just want to see the effect of the value inside the program counter when we execute the program. Okay, so the definition is contain the address of the next instruction to fetch and execute. Okay, so if you see this one, okay, so so this is your body of your program. Okay, move the byte and the byte. So this program will start at origin address location of 1000. Okay, so this is the program counter. Okay, this is the program counter. So we are at the start of your execution, you are not executing anything, but it already put the value of 1000 here, meaning that this one at low memory address location of 1000. Okay, 1000. So the function of the program counter is to determine where is the memory location. So it determine the system need to execute at the line. Okay, so at the first line the memory location is at 1000. Okay, so program counter will have the value of 1000. Okay. Okay, the function, so we turn back to the function contains the address of the next instruction to fetch and execute. The next instruction. So the next instruction, now I will try to execute the first line. So the next instruction is the next instruction will 1004. 1004. So okay, so the program counter will have the value 1000 for address location 1004. Okay, so if I continue to execute the next line, it will the program counter will have the value of 1008. 1008. Okay, this one 1008. Okay, so if I try to proceed it, I think this one is at uh, location as 1000A. This one 1000A. So that is the end of the code. Okay, so basically the program code is quite simple. It just put a value of the at the memory location where the instruction need to be executed. Okay, for what from 1000 to 1004 to 1008 to 1008. Okay, so this is your your machine code. This is your machine code 123C. So you also uh, can see the machine code at the memory 1000, because now your origin is at memory location 1000. Okay, so you can see the at 1000, this is 123C, 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 000A, 000A. Okay, and then 1004, this is 1004, 14, 14 3C, 14 3C, 000A, 000A. Okay, and then 1008, there is a D401, D401. Okay, so depend on the origin memory location you set in your program. If you start from memory location of 1000, so it will start, the machine code will start at 1000. Okay, 123C, 00AA, 0000A, and so on. Okay, so quite simple for the program counter. So now how about we proceed on the status register. So this is the status register. Okay, register bit 60, register status 16 bit. So how it's function? Okay, status register, it is a size, it have a size of 16 bit, contains information on the result of the last instruction. Consists of the system byte and the condition code register. Okay, so back to the chapter 4 slide. So this is the flag. So we can call it as flag. Flag meaning it show it is if it is done, if it comply the requirement, so it will set to 1. Okay, if it's not comply to the requirement here, so it will clear to 0. Okay, so we start on the first CCR. Okay, which is carry. Okay, carry. So the carry flag C, and I also will also explain about the flags X, because the flags X will just follow the result in flag C. Okay, what is C? C is carry. Okay. Okay. Set if a carry occurs during addition operation or shift operation. Okay, this one I highlight first. Set if carry occurs during addition operation, shift operation, or if set if borrow occur during subtraction. Clear otherwise. Okay. So what we have learned from the primary school, the addition and subtraction sometimes require us to carry and also to borrow. Okay, so if there is a carry and borrow operation occurs during the addition or subtraction, so it will set meaning the value of the flag C will become 1. Okay, the flag X extend copy the carry bit for arithmetic operation. So flag X just follow the flag C. Okay, if C 0, flag X will 0. If C 1, flag X will produce one value of 1 also. Okay, so I repeat, if there is a carry and borrow occurs during the addition and subtraction operation, so it will set to the flag C to 1. Okay, if there is no borrow and carry operation, so it is clear. Okay, clear meaning the flag C will have the value of 0. Okay, okay, let's try example. Okay, so for this, try first we try to uh, additional operation first. Okay, for example, we want to add uh, 0a plus 0a. So you need to have 2-bit hexa or 16-bit binary. Okay, 0a is 0000, a is 1010. So this one is in binary. Okay, 0000. Okay, 01010. Okay, try to add this one. Okay, 0 plus 0, 1 plus 1 will be 1 plus 1. So it will produce 1 plus 1 in decimal will become 2. 2 in binary is 1 0. So this one 0, there is a carry here 0. Okay, 1 plus 1 0. Okay, carry here. Okay, so what does the meaning of carry? It is at this position. Okay, if there is, like this example, there is no carry out. Okay, no carry out, so meaning the flag C will have the value of 0. Okay, so how about we try to see an example. Okay, so this one easy 68k. So set the value 0a to d1, 0a also to d2, and then try to add between the data register d1 and d2. Okay, execute. Okay, this one you now just focus on the value of C and X. Okay, when the value of C 0, the extent, the flag X will just follow the C value. Okay, okay, so first we set the value of D1 and D2. Okay, A and A. Okay, as what we have calculated before, there is no carry out, so supposedly the value of C is 0. Okay, so we can see here, you focus on this one. Okay, this is the status register. So see you how to see the status of the flag C. This one C0. Okay, this one we will cover later. V0, Z0, N0, X0. So the C is 0. Okay, this one already execute. Because why the value of C is 0? Because there is no carry out. Okay, so how about we try another example. Okay, for example, AA plus AA. So AA is 1010 1010 1010 1010 base 2 so add. So if we add this, we will get 0 0 1 0 1 0 1 1 1 0. There is a carry out here, so this is carry out. So when there is a carry out, so the status of flexi will become 1. Okay, will become 1. Okay, let's try to simulate. Okay, this one the first, this one is the if 0a plus 0a, so try to, okay, so sorry, carry. Okay, this one is, I try to simulate this example, AA plus AA. So the value of the flexi should be 1. Okay, should produce value of 1. So AA, and then add dot byte D1 plus D2. So execute this one, just setting the D1 and D2, and then add dot byte. So you will need to focus to this value. Okay, then execute. So you can see here that the C change status to 1. The extend just follow the value inside the C. Okay, inside the flex C. So C1, X also 1. Okay. So I hope you understand how the CCR code C function. Okay. If there is carry out, the C will set to 1. If there is no carry out, okay, for example, this no carry out, C will become 0. If there is carry out, C will become 1. Okay. So I have another example for the carry out, but this time around for the subtraction. Okay. So the why I want to uh, execute this program, because this one is 0 minus a. So if 0 minus a, so it will produce set when we set the D2 to 0. So how about we try to see the result first. Okay. Okay. So this one just to set D1 to AA, D2 0, and then subtract D2 with D1. Okay, focus on this carry value C. So the carry value will change to C, to 1, and the flag X just follow the value of C. Okay, so if you try to calculate 0 0 minus AA, there will be a carry out. Okay, so therefore the value of C become 1. Okay, we change status to 1. Okay, next is, Okay, so next is finish on the C, flag C, carry, and also extend. Okay, extend, if you can see the function is just to copy the carry bit for arithmetic operation. So X just copy the value of flag C. So extend is the most simplest one lah. Okay, if C is 1, X 1. If C 0, X 0. Okay, next is 0. Okay, try to see the definition of the flag Z, which is 0. Set if the result of operation is 0, clear otherwise. So this is also simple. If you're performing especially the subtraction operation, okay, 0 AA minus AA, for example, you will definitely get the answer of 0, so it will set to 1. Okay, the 0 flag will set to 1. If the answer is not 0, the 0 flag will set to 0. Okay, okay, let's see example. Okay, this one is also simple. For example, AA minus AA. Okay, 1010 1010 1010 1010 minus. Of course, you will get 0, all 0. So this will produce, if the answer is 0, so flag Z will produce 1. Okay, okay. If for example AA minus 1A, so definitely it will not produce 0, the answer of 0, right? So Z flag will change the status to 0. Okay, so how about we try to simulate for 0 flag. Okay, okay, this one AA minus AA, so definitely will get the, if you subtract subs dot b d2 minus d1, so we'll get the value of 0. So the flag Z will definitely produce, will change status to 1. Okay, you have to focus this Z, this one Z. Okay, try to trace one line by one line. Okay, so previously Z is 0. Okay, after I try to execute the sub dot byte, so what happened? So the Z status will change to 1. Okay, so because you get the answer of 0, so the Z will change to 1. Okay, so how about we try to see another example. So this one is different. BB subs D251. Okay, so BBAA, so you will definitely not going to get the answer of 0. So the Z flag will definitely produce 0. Okay, this one Z 0. So after you execute everything, it's still producing the value of Z 0, because you not get the answer of 0 when you subtract BB to A1. Okay, so I think it's quite simple. Okay, for 0. Okay, set if the result operation is 0, clear otherwise. Set meaning 1, clear meaning 0. Okay, so next flag is N. This one, N. Okay, N. Set if the result operation is negative, clear otherwise. Okay, so this one, okay, negative, okay, based on the definition, negative, the definition of negative is when the MSB is 1. Okay, so let's try to do some example. Okay, so for example, if your answer, you get the answer of 1010, okay, binary, so if 1 meaning the MSB is 1, okay, so negative flag will change status to 1. Okay, if 0, for example this one 0, so when MSB is 0, negative flag will maintain value of 0. Okay, so for example, if we perform addition operation, AA plus AA, okay, 1010 1010 1010 1010, you plus it. Okay, so the answer will become 0, this one 0 1 0 1 0 1 0 1. So what is the MSB of this answer? This is the MSB. Okay, this is not the MSB, this is carry. So don't get confused with MSB of the answer or the carry of this answer. Okay, for flag N, you need to consider this one, not this one. This is carry, so this will be considered in the flag C. Okay, so for previously, if there is a carry out, flag C will trigger to the value of 1. Okay, but for the negative flag N, which is negative, you have to see the MSB of this 8-bit binary numbers. Okay, so for this one, MSB is 0. So the flag N will change to 0. Not change, will have the value of 0. Okay. Okay. Another example, if you try to add AA plus 2A. Okay. So AA is 1010 1010. Okay, 2A is 0010 1010. Okay, plus. So 0 0 1 0 1 0 1 1. Okay, so what is the value of the MSB? So this one produce MSB 0. MSB not 0 1. So if MSB of the resultant of this operation producing 1, MSB is 1, so the N will change to the 1, to the value of 1. Okay, so let's try to see the example. Okay, 0 and not 0, negative. Okay, this one I set the for the D1 AA, D2 AA, Okay, D3 to A. Okay, so try to simulate first, execute. So we'll focus on the N. Okay, this one N. Okay, so AA D1 A so D1 has a value of AA. Okay, D2 also AA, D3 to A. So now the first one is the example. For this example, AA plus AA. Okay, AA plus AA. So as I have calculated before, the MSB is 0. So the N will not trigger to 1. So it maintains to value of 0. So observe this one. You need to observe this one and 0. So it maintain N 0. Okay. So add dot by D1 D3 minus this D1. So this one is I try to simulate this one. AA plus 2A. Okay. AA plus 2A. So add D1 and D3. D1 is AA, D3 is 2A. So add, not subtract. Add, sorry. I mentioned subtract previously. So if you try to add this AA and 2A, you get the MSB value 1. So flag N will trigger and change the status to 1. Okay, so we will see on the value in the flag N. So the N will change to 1. Okay. Okay. So I hope it clear about the N. Okay. Set if the result if the MSB the result operation have MSB of 1. Clear if the MSB is 0. Okay. So this one MSB 0 and 0. MSB 1 and 1. Okay. So we have covered carry, extend, 0, negative, and the last one is overflow. Okay, well, first this one is a little bit hard compared to other flags. Okay, so the definition is overflow is the short name of the flag is V. Okay, overflow V. Set if an addition of two numbers with similar sign or subtraction of two numbers with different sign change the destination sign. Okay. So for this one, it is for easier understand. You need to go to this slide 50. Okay, the effect of add instruction to the flag V bit. Okay. Okay, the definition is overflow. Uh, Change the destination sign. So the keyword is destination. Okay, not the source. Okay, so if you see here, okay, for example, the value of your source is positive. Okay, this is first is for addition. Positive, negative, definitely always V0 because the keyword is if addition two numbers with similar sign. Okay, similar sign meaning either positive plus positive or negative plus negative. Okay, if positive plus positive, you get change the destination sign, you get the answer negative, so the V will change status to 1. Okay, if you try to add negative value plus negative value, and you get the value of destination positive, so it changed the destination sign, so the v will also will change to 1. So this table will summarize how it's actually function. Okay, positive, negative definitely will not going to execute. For the overflow flag is always 0, v0 v0, because it's the source and destination does not have the same sign. Okay, okay, this one, okay, positive positive. If the answer positive, overflow flag will maintain 0 value because it does not change the sign. Okay, see here the definition: change the sign, change the destination sign. Okay, so if the source destination positive positive and the answer is positive, it will not going to change the value of the uh, flag v, it maintains 0. But if you try to add positive value to positive value and the answer is negative, so it change uh, the sign of the source and destination, so the flag v will change to 1. Okay, so this one, if source negative, destination negative, if you get the answer positive, so it change the sign of the source and destination, the flag v will become 1. Okay, but if the sign of the answer does not change, negative negative, you get the answer negative, so the v still 0. So the flag v still maintain 0 value. Okay, okay, for subtraction. Subtraction is a bit different from addition, because subtraction or subtraction of the two number with different sign, and then different sign, and then you need to see the destination result change or not. So this one, okay, subtraction, positive positive. Okay, for subtraction will not work out, always 0, because the rule is for the subtraction the source and destination need to have a different sign. So positive positive always v0, negative negative also 0. It is different from this one. Okay, for additional, if the sign of the source destination different, always 0. Okay, for subtraction it's different. If the positive positive means same sign, always v0, negative negative also v will maintain 0 value. Okay, this one, okay, negative positive. Okay, so if positive v0, because why? Because if the answer is positive, it is same with the destination sign. Okay, so for subtraction you really need to take care of the destination sign. Okay, if the value of positive, if the answer is positive, okay, which is same with the destination sign, also positive, overflow v maintain 0. Okay, but if you get the answer negative, which is different from the sign at the destination, so it will produce the v1. Okay, so this one uh, is quite tricky, but you need to try to understand this one. Negative positive, if positive is same with the destination, with the destination sign, v0. But if it is different from the destination sign, destination sign is positive but the answer negative, so the v will trigger to 1. Okay, Okay, same goes to this one, positive, negative. If you get the value positive, which is different from the sign of at the destination, this one is positive. This one, the sign at the destination is negative, so it will trigger to 1. Okay, but if you get the answer positive, negative, you get the answer negative, it will, and the sign at destination also negative, it will maintain overflow flag V to 0 because it does not change the sign at the destination. Okay, okay, let's see example. Okay, try to add AA and AA plus AA. Okay, this is in hexa value. So 1010 1010 2 base 2 1010 1010 base 2. Okay, so 1, so this one represent negative value. Okay, this one also negative value. Okay, plus. So 0 0 1 0 1 0 1 0. So this one is 0. So it is positive value. Okay. So this one, both this one negative. The answer positive. So does it change the source? The answer does it change from the source and destination? So it changed from negative to positive. So the V status will become 1. Okay. Okay, similar to the this one add, uh, we try example subtraction. For example, sub 2A minus AA. Okay, so 2A is 0 0 1 0 1 0 1 0. AA is 1 0 1 0 1 0 1 0. Okay, so this one is, so the subtraction, the source and destination need to different value. Okay, 0 is positive, 1 is negative. Okay, so this is the uh, destination, so this is the source. So what is the answer? Okay, if you subtract this one, 0 0 0 0 0 0, this one become 1. Okay, this one become 1. So you can double check using your calculator. So this one is negative. So we go back to the definition. If subtraction, to this table, subtraction. So this example, destination is negative, destination is positive, source is negative. So destination is positive, source is negative. Okay, so if you get the answer negative, so the overflow flag V will become 1. Okay, so now you get 1. So destination positive, answer negative. So does it change? So if there is changes, so flag will change to 1. Okay. Okay, let's try to see in the easy 68K. Okay, so this one, slide 52. Okay, so this one, I set the value of D1 AA, D2 AA, D3 AA. Okay, so try to execute. Okay, so D1, D2, and D3, AA, 2A, and 2A. So this one is D1, add D1, D2, add AA with AA. So AA and AA. So the flag V should be 1 because it produces a different sign from the source and the destination. Okay, so try to see the result here. V, focus to this one, V. So it changed to 1. Okay, it changed to 1. Okay, because of this. Okay, because of this. Okay, and then next is D3 minus D1, 2A minus AA, which is this one, 2A minus AA. Also, this one is subtraction, I think. Okay, subtraction. Okay, subtraction. So the answer sign, the sign of the answer have a different sign from the destination. Okay, so you have to see to compare between the answer and the destination for the subtraction operation. Okay, not compare between the sign of the answer and the sign of the source. So we'll definitely get a wrong answer. So compare with the sign of the answer and the sign of the destination. So also V will trigger to 1 because it has different sign between the answer and the destination. Okay, so this one will not change. Okay, not change. V always 1. We maintain 1. Okay, so how about another example? So this one is add but doesn't follow the rule. Okay, as I mentioned earlier, for add the value need to be same in order to execute to this stage. Okay, if the value is different, positive, negative, negative, positive, different at the source and destination, the value of the the V flag is always 0. Okay, this one just to test when the because AA is what? Okay, AA is 1010. Okay, AA is 10101010. Okay, 2A is 00101010. So it is it does not follow the rule. Okay, the sign difference. Okay, will definitely V maintain 0. Okay, this is for addition. For addition. Okay, so if addition, if does not follow this rule, definitely always v0. Okay, okay, v does not change, maintain v at 0. Okay, so we have covered the CCR for C, V, Z, N, and X. Okay, and also at the earlier lecture I have covered on the program counter. So I think that's all for this lectures series. So you this one is example, you can try also this example. Okay, try to do some exercise to strengthen your understanding. I think that's all for this chapter 4, arithmetic instruction. uh, Thank you very much.